this problem from constrained motion of particle dynamics, or we say that this is a problem of cycloidal motion, and the problem is a heavy particle slides down the arc of a smooth cycloid whose axis is vertical and vertex downwards. Okay, so we draw a rough sketch of cycloid like this. This is the cycloid. Okay, this is the cycloid, and we know that these two are the two curves A and B. Let the vertex be at O. Okay, this is the cycloid, and we know that the intrinsic equation of the cycloid is S. This is equal to 4A sin psi. We name this relation as 1. Okay, if it starts from rest at a cusp and arrives at the vertex. Okay, so the particle starts from a cusp A and arrives to the point O, that is the lowest point of the cycloid. Prove that the time occupied in falling down the first half of the vertical height is equal to the time falling down the second half. So we have to find the vertical height of the cusp from the base. Okay, let it be the middle point, and this is middle point M. Okay, now we draw a tangent, any tangent at the point. Sorry, this is not a tangent, this is a tangent at the point P, and since the particle is given that a heavy particle, so the mass, that is the weight mg, act vertically down. Okay, and this is the direction of positive velocity, but the particle is moving from A to O, because this is the cusp. Okay, and we know that the normal reaction act along the inward normal. This is R, and here the tangent at P makes angle psi with horizontal. Right, so we say that this angle be pi by 2 minus psi, and the component of mg along the normal, this is the negative normal, this is mg cos pi by 2 minus psi, pi by 2 minus psi, this is mg. So this is mg sin psi. Now we consider the tangential equation of motion at the point P. This is the general point whose coordinate is S psi. This is the intrinsic coordinate, and the equation of motion in tangential direction is m v dv ds. This is equal to minus mg into sin psi. We take minus mg sin psi because this force try to decrease the value of S, because here we know that S, this is equal to 0, and psi, this is equal to 0 at the vertex. Okay, and at the cusp we know that psi, this is equal to pi by 2, and from here S, this is equal to 4a sin pi by 2, this is 4a. Right, now to relate S with y, that is the vertical height, we put here S, this is equal to 4a into dy ds, because we know that in differential calculus dy ds, this is equal to sin psi, and we get by integrating S ds, this is equal to 4a into dy, so this is s square by 2 4ay, and and integrating constant C1. Now put the initially at the point vertex O. Here S, this is equal to 0, and at the lowest point or at the vertex Y must be equal to 0. Okay. So we get C1, this is equal to 0, that is we get S square, this is equal to 8AY. This is an important relation of cycloid, and this is the relation between arc length S and the vertical height Y. Okay. Now putting the value of S at the cusp, we get, if we put here S equal to 4A, then 4A whole square, this is equal to 8AY, imply Y this is equal to 4A, sorry, this is equal to 2A. So here Y at the cusp, Y equal to 2A, and at the middle point it is obviously Y equal to A, and at the lowest point if it is N, then Y equal to 0. We have to find the value of the time from Y equal to 2A to Y equal to A, this is T1, and let it be T2. Y equal to A to Y equal to 0, it be T2, and we have to show that T1 this is equal to T2. Since it is proved that first half of the vertical height is equal to the time of falling down the second half. Okay, this is our required proof. Now here, when Y equal to 2A, then we get S equal to 4A. But when Y equal to A, then from this relation we get S square, this is equal to 8A square. So we get S, this is equal to 2 root 2A. Okay. So at that point, that is at the middle point, here S, this is equal to 2 root 2A. And at the lowest point, S, this is equal to 0. So we have to integrate S equal to 4A to S equal to 2 root 2A, and again integrate S equal to 2 root 2A to S equal to 0, and then find the value of T1 and T2. Okay. Now we proceed as we first cancel out the mass from both sides and putting the value of sin psi from this relation, that is the relation number 1, and get V dV ds, this is equal to minus G into S by 4A, because sin psi this is equal to S by 4A, and integrating we get V dV, this is equal to minus G by 4A into S ds, so V square by 2, this is equal to minus G by 8A into S square plus C2. We use the initial condition. It is given that the particle start from rest at a cusp. So at the cusp A, V equal to 0 and S equal to 4A. So we put here V equal to 0 and S equal to 4A. We get C2, this is equal to 2AG. Okay. Now putting the value of C2 here, we get V square by 2, this is equal to minus G by 8A into S square plus 2AG, right? And this gives V square, this is equal to 4AG minus G by 4A into S square, and we take common G by 4A and we get, this is 16 S square minus S square, and we get the velocity V, this is given by root G by 4A into root 16 S square minus S square, and we take here a minus sign because the velocity in the downward direction, that is the decreasing direction of S, we we measure the arc length s from the vertex, and vertex is on the lowest point. Okay, so velocity try to decrease the s, so we get ds dt, that is the velocity is negative. Now we write from this relation ds by root under 16 square minus s square, this is equal to minus g by 4a into dt, because v, this is equal to ds by dt. Okay, now here already we take the required time for the first half is t1 and the required time for the second half is t2. So from this relation we get the integration for the first half is g by 4a into integration 0 to t1 dt. Here we write for the first half. Okay, and the left side integration is s equal to 4a to s equal to 2 root 2a ds by root under 4a whole square minus s square. Now integrating the above result, we get sine inverse s by 4a, this is equal to minus g by 4a into t1. Okay, and the range of the left hand side is 4a lower range and upper range is 2 root 2a. Now putting the range, we get this is minus g by 4a, this is root g by 4a, here also root g by 4a, this is root g by 4a into capital T1, this is equal to sine inverse s means 2 root 2a by 4a minus sine inverse 4a by 4a. Okay, so this is a cancel out, so we get sine inverse 1 by root 2 minus sine inverse 1, that is we get pi by 4 minus pi by 2, and this is minus pi by 4, and t1 is given by root 4a by g into pi by 4. This is the required time for the first half. Okay, and the time for the second half we get in similar manner by changing the order of integration. This order of integration be 2 root 2a to 0. Okay, and get the result as minus g by 4a into t2. Here the range is 0 to t2, so we get here t2, and this side is sine inverse s by 4a into this is 2 root 2a to 0, and by putting the range we get the first range or the upper range, this is 0, sine inverse 0, and for the lower range is sine inverse 1 by root 2, so it is pi by 4, and from this relation we get t2, this is equal to also 4a by g into pi by 4. Okay, so we get the result, the value of t1 and the value of t2, and from both the value we say that t1 this is equal to t2, that is the time in falling down the first half of the vertical height is equal to the time of falling down the second half. Okay, this problem is also from your previous year question paper also. Okay, thank you for watching.